Hello, everybody. Welcome back to AI Reset to Zero with Neil Makwana and myself. We have a fun topic for you today on AI robotics, humanoid robotics to be particular. But we've been talking a lot in the last couple of shows about large language model robotics, all the stuff that's going on. Last week we talked about Johnny Ive and Sam Altman coming together at OpenAI to build the next array of devices for the physical world, physical AI. This is a market that investors both on the public side and private side are very excited about. Private market is basically creating robotic company financings in the billions of dollars, and it's a very active area. In the US, Elon Musk has staked his company Tesla on Optimus humanoid robots. Is forecasting that he will have millions of these robots out in the marketplace doing useful things for us, both in our homes and in businesses. That these things, we will be able to buy them for the price of a car, $20,000, $30,000. They'll help us do lots of things. And so, Neil and I are very excited about this as well. I happen to think this is going to be also a multi-trillion-dollar opportunity, but over a long period of time, not necessarily the next few years. We'll see a lot of cool things over the next few years, but for this to be a mainstream market, I suspect it'll take us maybe a decade or longer. But we can talk about that separately. What we thought we would do here today is explain a little bit why the robotic market is so exciting, but it's very different in terms of how it will evolve relative to how large language models, ChatGPT, has evolved. And one of the key differences is around data. Neil, if we put up the tech stack chart, this is our AI tech value stack, which we recently updated for the third quarter. But this breaks up the technology stack in terms of infrastructure in the lower three boxes, and then the top three boxes has all the software services type of companies. And this is the version of the chart that actually has the companies. So there are some examples of representative companies. But this chart is really talking about the large language model data world, where you have the NVIDIAs of the world in box number 1 and 2, and then you have OpenAI and Anthropic and all of these companies creating the large language models in box number 3. And very different relative to the PC industry and the other technology waves is this box number 4, data. The reason we have ChatGPT and large language models is they've been able to harness the data from the broad internet through services like Wikipedia, Reddit, and so many other things, and literally created the data to train the AIs to do all the magical things. We use them every day, whether through voice, text, prompts, etc. And today, the top scientists in the field are worried that the data for just this part of the internet is now running out. And I couldn't disagree more. I think the data we have is just the tip of the iceberg. I have several posts on this and that I will put in the show notes for you all if you want. But the problem for getting data is even bigger on the robotic side of the market, because guess what? There are no robots. There's no Wikipedia. There's no data to train the models. And so we're going to go in a little bit into this and weave some clips from very prominent scientists and tech executives talking about this. And I think it'll be fun to have this discussion. But let's just take a step back and think about how we as mainstream users were introduced to robots in the first place. One of my favorite movies, and Neil, I think this was before you were born, before this movie, and this movie was a hit, was Star Wars. We were introduced to two cute robots, R2D2 and C3PO. And I think it's fun to kind of maybe watch a clip to remind ourselves why we fell in love with early on through science fiction. Obviously, there were books, Isaac Asimov, and so on. But for mainstream people, it was movies. And this is a good reminder. Let's play the clip.
How did we get into this mess? I really don't know how. We seem to be made to suffer. It's our lot in life. Where do you think you're going? Well, I'm not going that way. It's much too rocky. This way is much easier. What makes you think there are settlements over there? Don't get taken.
And there we go. We have R2D2 talking to a humanoid robot who actually speaks English probably better than I do. That's the world we're going toward, hopefully. But that interaction was endearing, and the whole movie was extraordinary. Obviously, go watch it again. I watched it at least 24 times. Right, Neil?
Yeah, I mean, this kind of it's funny how like movies set this precedent for what technology will end up being. I mean, science fiction in general. So it's just seeing what we have here and then showing you what we're going to see in the next few clips. It's really amazing to see how far we've come.
And by the way, every founder of all the tech companies we know and love, whether it's the Google guys or the Meta guys, they were all influenced by this stuff. And what they're doing in many ways is either actively or subliminally guided by this stuff. We talk about voice AI last podcast. Voice translation, universal translator, that comes from Star Trek. And that's what Johnny Ive and Sam are going to try and build. These two robots, Jensen Huang, who founded and leads one of the preeminent AI companies, did for the last 2 or 3 developer conferences, which is called GTC, he's gone out of his way to show toward the end of his presentations this business about physical AI. And NVIDIA is playing a very big role because they've got a whole host of both hardware and open source software to encourage the growth of this robotics market. At the last GTC, he had a presentation on the robot side, which I think it might be worth watching a couple of minutes of in terms of why he's excited about and introducing this new area. Why don't we play that clip where Jensen Huang at a GTC conference talking about AI robotics for about 2 or 3 minutes.
And so today we're announcing something really, really special. It is a partnership of 3 companies, DeepMind, Disney Research, and NVIDIA, and we call it Newton. Let's take a look at Newton. Okay. Tell me that wasn't amazing. Hey, Blue. How are you doing? How do you like your new physics engine? You like it, huh? Yeah, I bet. I know. Tactile feedback, rigid body, soft body simulation, super real time. Can you imagine just now what we're looking at is complete real time simulation? This is how we're going to train robots in the future. Just so you know, Blue has 2 computers, 2 NVIDIA computers inside. Look how smart you are. Yes, you're smart.
Awesome. So I mean that one is Steve Jobs probably maybe could have done it a touch better, but that was pretty cool the way it was done. And what do you think?
I mean, it's amazing. I mean, obviously this is done in partnership with Disney. I mean, this evokes R2D2, C3PO, and even like the BB-8 robot from the newest ones. I mean, this like you would have thought it was a rendering the first thing they showed. The fact that they brought it on stage, it was able to interact. It was a live model. I mean, this is this is where we are. This is where the shift is. I mean, it's just it's amazing.
And you mentioned rendering. The first part of that clip where you see the robot in the desert, like we saw R2D2. When that R2D2 was done, that was CGI, and the early days of CGI in the 70s, etc. It was mind-blowing back then, which was actually one of the companies involved was actually Steve Jobs. ILM, Industrial Light and Magic, ended up buying that and kind of led to Pixar, which had its own history. And, that's where Pixar was where Steve Jobs made his first billions before he made any billions on Apple, believe it or not. So there's a long kind of interconnected robot, and Pixar had a wonderful movie called WALL-E, which I would recommend everyone watch. It's one of the best, as important as Toy Story. But aside from that, that blue robot in the digital rendering was not CGI. That was all synthetic data, synthetic rendering simulations. And we're going to talk a lot about that in the latter part of this show, because that synthetic generation, all through graphics cards and creating these simulations, is where we're going to go with making humanoid robots real at scale. And that's a very interesting part of the story that we need to touch on. And Blue, that was on stage, is the first incarnation of this. Now, as I mentioned, Jensen has a whole robotics group, and one of the senior people there is a fellow by the name of Jim Fan, who's longtime roboticist and language model specialist from Stanford, etc. He's done wonderful work around teaching language models through games, just like the senior researchers at DeepMind, which is Google, Sir Demis Hassabis, the AlphaFold and all the amazing work Google's doing. Same thing at OpenAI. They innovated around games before they got to ChatGPT. And Jim Fan did a lot of original work with Minecraft and other things, that teaching computers how to play Minecraft automatically. But he is leading the charge at NVIDIA on robotics and how do we make this vision real. And he did a presentation at a VC conference at Sequoia, which has a few minutes of clips that I think will be very helpful to crystallize where we are relative to large language models that were even earlier than that, and how much work there has to be done. That's the bad news. The good news is it'll likely happen very fast, not months, but a few years. But the work is being outlined. So let's play a clip of Jim Fan from NVIDIA. He actually at this conference followed Jensen Huang, so he'll make a reference to Jensen. But here we go.
So a couple of days ago, I saw a blog post that caught my attention. It says we passed the Turing test and nobody noticed. Well, Turing test used to be sacred, right? It's the holy grail of computer science, right? The idea that you can't tell the difference between a conversation from a human or from a machine. And then it just so happens that we got there. We just got there. And, like people are upset when
Neil, pause that.
Mini took a few more seconds.
We did get there, right? We talked about it last show with Sam Altman doing the simulation of the voices, Scarlett Johansson. So we passed this Turing test. So I just wanted to underline that point because it's an important one, and now all of us can chat through ChatGPT and Perplexity, and we have a very human-like sounding voice, and they talk in multiple languages. We take it for granted, but this Turing test, this was a holy grail in computer science for 30 years. AI is a field that's been around for over 30 years with lots of ups and downs. In the last 3 or 4 years, we're just seeing the result of all this work that's been done. And so it's very easy to take it for granted across the generational divides. But this took a long time coming, so we need to applaud that. But what he's talking about is what's beyond the Turing test for the world of physical AI.
Seconds to think, or that Claude is not able to debug your nasty, nasty code, right? And then we shrug off every LLM breakthrough as just yet another Tuesday. You guys in the room are the hardest crowd to impress. So I would like to propose something very simple called the physical Turing test. And the idea is like this, right? You host a hackathon party on a Sunday night, and this is what you end up with. Your partner's yelling at you, and you're like, damn, on Monday morning, I want to tell someone to clean up this mess and make me a very nice candlelit dinner so my partner can be happy. And then you come home to this, and you cannot tell if this was from a human or from a machine's work, right?
Brilliant. That is a, it's a moonshot type of call. It's like JFK saying in 10 years, we're going to land a man on the moon when they could barely get a little dinky thing into orbit. It's a great Turing test, and it will likely happen faster than we all think. It's not going to be hopefully decades, but it's not right around the corner either. There's a lot of work to be done, and we're going to see some of the work. And Jim goes on to explaining the difference in terms of training and data for language models and where we are with robots. So let's play that clip.
You guys know that LM researchers complain a lot, right? They complain a lot. And recently some guy named Ilya complained He said,
Just pause.
LLM
Sorry.
training is running.
Ilya, just to give context for people who might know, because he's talking to a group of techies and so on. This is Ilya Sutskever. He is one of the co-founders of OpenAI. He's one of the core genesis of ChatGPT, etc. One of the top engineers in the world. He has his own company now called Safe Superintelligence, and he's building Safe AI. And he did a very famous presentation. I had a post up on it. We'll put it in the show notes, where he basically said the data for traditional language models was as at an end, but he's pointed ways that we could get beyond that for language models. And what Jim is using is that whole complaint by Ilya to set the stage for the same challenge in the physical AI world. Please play.
Running out of data. And he even called the internet the fossil fuel of AI. And he said, we're running out of data to train LLM. Well, just spend one day with roboticists, and you'll know that how spoiled the LLM researchers are. We don't even get the fossil fuel. So this is a data collection session at NVIDIA headquarters. There's a cafe in NVIDIA, and we have these humanoid robots set up where we operate them and collect the data. And this is what the data look like, right? The robot joint control signals. And these are continuous values over time, and you cannot scrape this from the internet. You can't find it on Wikipedia, on YouTube, on Reddit, anywhere. So you have to collect it yourself. And how do we collect it? We have a very sophisticated way, but also very expensive way called teleoperation, where you can have a human wear something of a VR headset that recognizes your hand pose and streams to the robot. And in this way, you can teach the robot what to do, like pick up a bread out of a toaster and then pour honey over it. But you can imagine this is a very slow and painful process, right? So if you put it on the scaling plot, basically it doesn't scale at all. The real robot data is the human fuel. It's worse than the fossil fuel. You're burning human fuel, and what's worse, it's at most 24 hours per robot per day. And in fact, you'll get much less than that because the human gets tired and the robots get tired even more than the humans. So this is what you get. And what to do, right? How to break this barrier. Where's the nuclear energy for robotics? We gotta have clean energy. Can't live on fossil fuel forever. Well, enter simulation. We gotta leave the physical world and then do something in simulation. So we trained this robot hand to do superhuman dexterous tasks like spin in a pen in a simulation. And well, it's superhuman with respect to me because I couldn't spin pen and I just gave up, a long time ago in childhood. And I'm glad that my robot, at least in simulation, can do it better than I do. So how do we train the hand to do a sophisticated task like this? There are two ideas. One is you got to simulate at 10,000 times faster than real time, meaning that you should have 10,000 environments running in parallel on a single GPU doing physics simulation. That's number one. And number two, the 10,000 copies of the environment cannot all be identical. You got to vary some parameters like gravity, friction, and weight, and we call that domain randomization. And that gives us the simulation principle, right? Why does it work? So imagine if a neural net is able to control the robot to solve 1 million different worlds, then it may very well solve the 1,000,001st world, which is our physical reality. So in other words, our physical world is in distribution of this training. And then how we apply this, you can build a digital twin, right? A one-to-one copy of the robot and the world, and then you train in simulation, you test it on the real world. Directly transfers, right? Zero shot. And you can do a hand. And this is the most impressive task that we could do. So basically you have a robot dog on a ball, and then we transfer that to real world.
Extraordinary.
This is at Penn, at UPenn, and basically someone walking the robot dog, our researcher, super weird, looks like a Black Mirror episode. And this is called Dr. Eureka. Actually, like one of the researchers tried his dog on the yoga ball. At least we're super dog dexterity right now. Yeah, the dog cannot do it. Right? And next, we can also apply that to much more complicated robots like the humanoid. And these humanoid robots, they went through 10 years worth of training in only 2 hours of simulation time to learn walking. And then you can transfer that. And it doesn't matter what the embodiment is. as long as you have the robot model, you simulate it, and you can do the walking. And can we do more than walking, right? So as we are controlling our body, you can track any pose that you want, track any key point, follow any velocity vector that you want. And this is called the whole body control problem of humanoid. And it's really difficult, but we can train that, right, on 10,000 simulations running in parallel, and we can transfer.
So that this whole video, by the way, is worth watching. We'll put up the links in the show notes. But we just wanted to take a couple of clips to kind of tell the narrative here. And you saw the simulation creating synthetic data, synthetic content is a path here. And it is a long path. And NVIDIA is doing this. There are a bunch of robots with humans and other things like that at Tesla. For Elon, Optimus is doing this. Every robot company is playing with this. And so globally, and by the way, huge amount of effort along these lines on China, which we'll talk about at the end of the program. So that's what they're doing. Let's play the next clip, Neil, and to show where this is going next in terms of scaling it.
So you have this embodied scaling law. Okay, so Jensen left, but I think he's gonna like this a lot, right? So you need a lot of compute, to scale up the classical simulation, and that's the Sim 1.x series. The issue is, as you scale this up, it's gonna hit a wall because the diversity is limited in this handcrafted system. And then this is the neural world models, the Sim 2.0, that's gonna scale exponentially with compute. And that's a point where the neural network outperforms a classical graphics engineer. And together, these two adding up, that will be our nuclear power to scale up the next generation of robotics systems. The more you buy, the more you say. The more you.
So
sell.
that's the hope, and that's not actually more than hope. That's the science, and this is what billions are being invested in right now to scale up humanoid robotics. It's a long path, and there's a lot of effort and energy going in. The Gen Z folks, like my dear nephew Neil, who just graduated with his master's in computer science and business, this is what they're going to help us build, and there's a lot of opportunity and a lot of excitement here. But you can see the palpable joy from Jim Fan on this. That was a key part of this, and that leads us to Neil. What is the next clip we want to show? Why don't you introduce it?
So kind of just like bookending how we started. We started with Star Wars, and we thought might as well just finish with another, sci-fi classic of the Matrix. So we're just gonna let this clip play, and then I think there's a lot of really cool discussion that we'll be able to have.
And it's obvious how Keanu Reeves was trained just like the robots. I still remember being in the theater when this happened, and the whole place just came down in applause. It was so exciting. And again, art precedes science, and this is an example of that. This is a joyous moment in the movies. Again, please watch it again if you haven't watched The Matrix. The others, the later sequels, not so much, but this is not a movie critique program. Although, Neil, we may want to do one of those.
Yeah, eventually we might do that.
So that is the inspiration, obviously, and the aspiration for where physical AI is going. We thought we'd introduce these issues and the complexity of the technology issues, the data piece, and then I wanted to just touch on a little bit, because today's geopolitical environment it's the whole AI world is being cast as a race between us and China. In an ideal world, China and the US and the world would be innovating together. Jensen talks about it himself. Half the researchers in technology and AI are overseas, are non-US born. And China right now is actually, in many ways, especially on manufacturing, is ahead of the US in robotic manufacture. They've been participating in as much as we're thinking about it as a political race, there's a lot of interesting things going on in China on robotics. They've got very interesting companies called like Unitree. I've written a lot about this. We'll put up some of the posts up in the show notes. But this was a recent post I did that talked about a race that was done in China just a few weeks ago, where in a marathon they had robots race along with humans. And this was a very interesting thing. There's clips of it you can watch if you want. But the core thing about it was that, spoiler alert, the robots didn't do as well as the humans today. But this whole thing was reminiscent of how the US government, DARPA, the Defense Research Organization, in the mid 2000s, sponsored a challenge for private companies to create an automobile or vehicle that could go through the desert for a few dozens of miles from point A to point B, totally self-driving. And that was the genesis of today's Waymo, full self-driving from Tesla and all the countries. It inspired thousands, tens of thousands of engineers and researchers to get on this challenge. And 15, 20 years later, we're still at what is called the level 2 of self-driving. Level 2 means you can drive mostly with steering wheels, people paying some attention to the steering wheel on the road. Level 3 was like companies like Waymo with no steering wheels. Level 5 is fully automated with no human interaction, no teleoperation, and driving through all kinds of weather, all kinds of roads, not just on highways. Again, still, a lot of people think it's only 2 or 3 years away. Bottom-up technical reasons, it's still years away, level 5. Robots are in the same league, but we're not even in level 2. We're not even at the ChatGPT moment of this. I remember, again, I'm dating myself, about 10, 12, 15 years ago, buying some of the first robotic dogs. You remember that dog on the ball? There was Sony had a product called Aibo. It was $4,000 or $5,000. I remember getting this. My family at the time saying, "Why are you doing?" The thing could bark, it could run around, chase a ball. That's it. And Aibo went nowhere, and I still have it as a collector item. Now we're going to have robots from companies, large and small, Apple, Amazon, etc., all working on home robots of all types, not just the humanoids. And that's all coming, but it's a long, long race. And it's going to be technologies like this. It's going to be technologists like my nephew Neil. We're going to need thousands and hundreds of thousands and millions of these folks to build this stuff. It's very exciting. And we just wanted to introduce the topic. Neil, do you want to add some more thoughts to this?
Yeah.
Journey?
I mean, a couple thoughts. I mean, just even though we are still early on in the stage, just the rate at which current training and testing has been done. I mean, you saw it in the Sequoia clip. He was talking about how they're able to simulate 10 years of simulations with humanoids in 2 hours. I mean, this is like, in for example, in the Matrix clip, obviously they don't show how long, but they said, in 10 hours he was able to learn Kung Fu. So I mean, this is really, it is accelerating at still a very fast pace. And with it being able to play games like Minecraft and whatnot, I mean, even going down the video game route, I mean, we know that GTA 6 is coming out, next year. That is, a fully human game where you're interacting with things, you're talking to people, you're moving with an environment. I mean, is there a potential avenue where stuff like that is being used to train these models? I mean, it's the rate of innovation is very fast, and even though we are a ways out from this kind of materializing in a product sense potentially, to just seeing the growth and how all these sci-fi concepts that no one would have thought is possible are kind of starting to become a reality is fascinating. I mean, even one other thing from the Sequoia clip, I definitely encourage you to watch the whole thing, is that at some point he mentions that you could even, this is kind of like a hint to where this could be productized. Obviously we know this is years out in the future potentially, but he was mentioning how they could get a Michelin star chef, for example, to come in and train a robot to try and cook a meal. And obviously Brian Chesky and Airbnb very recently announced, their complete overhaul of the platform, and how now you can Airbnb experiences. It's no longer just like homes and rooms, but you can Airbnb a Michelin star chef to come and cook for you, or you can Airbnb a tour of a museum by the person that designed the museum. So potentially there is a future in which these companies are able to employ robotics to kind of aid in these experiences. We could have a Michelin star trained a robot that is trained by a Michelin star chef to come and cook for you in your home. So I mean, it really is like the productization of this will be very interesting. Obviously, it is a ways away, but the same way that Star Wars kind of predicted the future of these humanoids. I mean, it'll be very fascinating to see kind of what is done on the product side of things.
I love that point about the Michelin star robots that's very akin to the hopes we have for robotaxis, that people will have their cars and they're 90% of the time they're unused in the parking lot. They can make money for you by doing things, and there's no reason why not just Michelin star cooks, but the regular cooks who make a great chicken pot pie or whatever can train these things, and these things can basically be downloaded somewhere where it makes stuff for you in your house on someone else's recipe. So the business models of this are open-ended. There'll be thousands of versions where we can barely imagine. And that's why, as investors, sometimes we like, oh, how will this make money? How will this do this? It's $20,000. It's all open-ended. It's all possible. And just like you mentioned Brian Chesky and Airbnb, because they just had a very important relaunch of the experiences program at Airbnb. That's very similar to, a few years ago, the Ubers and the Lyfts, were funding directly self-driving car research because they thought a lot of the drivers would be replaced sooner with self-driving cars. It took a lot longer. And now the Ubers of the world are actually becoming interesting partners for companies like Waymo and potentially for companies like Tesla as they build these robotic car fleets, because Uber has aggregated the marketplace for people wanting rides, people wanting food delivery, and so on. So world is the oyster for these companies in terms of robotic services, and that's a whole new thing we'll talk about. By the way, if you guys have any comments, thoughts, questions, ideas where you'd like us to consider future shows and topics around this or other things we've discussed, please, we welcome feedback. We want to thank you again for joining us today for another one of these shows. If you like the show, please, as usual, like and subscribe. And most importantly, though, stay tuned. Look forward to seeing
Thank
you
you.
soon again.
See you next time.